Section 4.7 is on inverse linear function. An inverse relation has a set of ordered pairs that is obtained by switching the x and y coordinates of each ordered pair. So our first example says to find the inverse of this relation. Notice we have a set of 5 ordered pairs. So to find the inverse, we're just going to take each ordered pair and switch the x and the y. So my first ordered pair, instead of being negative 2, 8, is going to be 8, negative 2. My second ordered pair will be 9, negative 1. My third, 13, 0. My fourth, negative 7, 1. And my last, 3, 2. Okay. Notice that I'm writing it in set notation with curly brackets on each end. And notice I'm not changing the sign of anything. I'm just flip-flopping the x and the y. This example asks you to graph the inverse of this relation. And actually, you should be aware that this relation is indeed a function because it is a linear relation. So I think the easiest way to do this is just to write this as a set of ordered pairs. So this point right here is the point negative 2, 2. This point right here is the point 0, 3. This point right here is 2, 4. And this point right here is 4, 5. And actually, if you look at this set of ordered pairs, you'll see that there is a pattern here. My x's are going up 2 and my y's are going up 1. Now, in order to get the inverse, maybe I'll go ahead and do this in a different color. I'm just going to rewrite each ordered pair with the x and the y flipped. So instead of negative 2, 2, I'll have 2, negative 2, and 3, 0, and 4, 2, and 5, 4. Now I'm going to graph those blue points. So 2, negative 2, 3, 0, 4, 2, and 5, 4. And I'll connect those points and draw the line through them. Okay, so the blue line is the inverse of the graph of the pink line. And actually, if you'll notice, this isn't something you need to know right now, but it's kind of cool because it'll come up later in your further math classes. If I were to take this line right here, which I like to call a perfectly diagonal line, it's actually the line y equals x. Got a little sloppy down there. You'll notice that the pink line, if we were to reflect it over the line y equals x, that is, reflect the pink line over the green line, we'd get the blue line. And that's indeed what an inverse is. An inverse function is written this way. It looks like it's f to the negative 1 power times x, but that's not the way we say it. That's just the notation. The way we say it is the inverse of f of x. You remember that we've used f of x before, but when we put that little negative 1 up there, it turns it into the inverse. This is also obtained by switching the x and y, but this refers to it as a function. So what we're going to be doing is writing the inverse of a function, and here are the 4 steps you have to follow. The first step is to replace f of x with y, and we've talked about this before, that f of x is just another way of saying y. Then we're going to switch the x and the y in the equation, solve the equation for y, and then undo what we did in step 1, and that is replace y with our inverse function notation. So let's take a look at an example here. We need to find the inverse of this function. F of x equals 4x minus 12. My first step is to replace f of x with y. So y equals 4x minus 12. My second step is to switch the x and the y. So instead of writing a y, I'm going to write an x. And instead of writing an x, I'm going to write a y. Now I need to solve this equation for y. Basically, put it into y equals mx plus b form. So I need to isolate my y. So I'll add 12 on both sides. And that gives me x plus 12 equals 4y. And now I'll divide both sides by 4. And so my 4's will cancel here. X over 4 is the same as 1/4 x plus 3 equals y. And I can actually, I think I'd like the looks of it better if I flip it around and say y equals 1/4 x plus 3. That looks a little bit better. And then our last step is to replace y with the inverse function notation, and that is the inverse of f of x equals 1/4 x plus 3. And that equation, 1/4 x plus 3, is the inverse of 4x minus 12. And our last example here asks us to find the inverse of this equation. Notice that this equation is not written in function notation. There's no f of x here. We just have an x and a y. So basically we can skip the first step. We don't have to replace f of x with y because there is no f of x. So my first step is going to be to switch x and y. So keep your coefficients the same, just switch the letters. Now let's solve this for y. Basically put it into y equals mx plus b form. So I'm subtracting 4x on both sides. And then I'll divide both sides by 3. And that gives me y equals negative 4/3 x plus 4. And then my last step, I do need to retain that. Use the inverse function notation, the inverse of f of x. Replace that for y is negative 4/3 x plus 4. So in this lesson, we learned what an inverse of a function is. Basically, or even an inverse of a relation. Basically switching the x and y coordinates. And if it's a function, you can write it in function notation using this inverse notation.